recycle aggregates, I just want to talk a little about the topic. Before we begin, let's just define what is meant by green. When we talk about green, if you look at the screen, there are all different colors ranging from black to green, but we cannot define when we actually can start calling any material green. Okay, some people can say that okay, it starts from 3, some can say start from 5, but it's all about relative index. So when we say is green concrete a reality, we should understand it's a relative index. It's not an absolute parameter that we have to achieve. We are looking at colors, we have a better sense of perception, but when we look at terminologies, there are lot of different terminologies which creates a lot of confusion. And is our material actually getting better or not? So these are the different type of terminologies when people listen and keep hearing about, but are they actually going towards green? So if you look about zero carbon, it sounds very good that there is no carbon emission, but it does not cover any other parameter, whether it is causing any other kind of emissions or pollution. So these terminologies are also very vague. So when we are talking about green, one should understand that it's only a relative terminology. It's talking about getting relatively better. We are not there towards a final solution. It's just relatively better to what we have. And then comes about perspective. Like if we are looking at a cube, it all depends from which angle we are looking at the solution. A concrete, which sir just talked about, AAC block, it's a sustainable solution when we are talking about walls. But when we are talking about load bearing structures, AC cannot bear load. So then it's not even a viable solution in those applications. So it's just about in the defined application, then only we can talk about whether the material is becoming green or not. About recycled aggregate. So when we talk about recycled aggregates, we should understand that construction is one of the highest resource consuming industry, and in this industry itself, aggregate occupies the most amount of resource consumption share globally. In India, it is estimated that the annual consumption of aggregates estimates in the range of 2600 to about 2600 million tons. But when we talk about looking at the alternatives, there are a lot of alternatives people talk about, like this can act as an alternate aggregate, this can act as an alternate aggregate. But if we look at their availability, we can see that they are not even available in enough quantity to even meet the half the demand of this industry. People should understand that when we are talking about there's one solution, it's not there will be a perfect solution. We have to look about all the solutions and try to optimize whatever is available with us, and try to explore as many solutions as possible when we are talking about alternate aggregate. Recycled concrete aggregate is one of the best solution that can meet the largest demand of the country, but it's not the perfect solution as of now. Even when we are talking about the recycled aggregate, we should understand there's very limited use going on in the industry, and major problem when we look about it is comes to the how the waste is being managed. The current practice as of now does not include segregation and management practices. As a result, mixed recycled aggregates are generated. There are like bricks and other organic impurities that are present in the recycled waste, which do not give good quality properties. For in global context, when people are advocating the use of recycled aggregate, they are mostly talking about recycled concrete aggregates, because this segregated waste gives typically good results, and its use is viable. So when we are looking at the problem, we should understand how the Indian context is working. So current in line with the new the new guidelines with the ministry that will be implemented with the effect from April 1st, 2026, I will talk about the two scenarios that we will be facing in India. First is about the large builders. They have to segregate and manage this waste. They can talk about recycled concrete aggregate, they can talk about its proper utilization. A lot of different solutions are available. But when we are talking about small construction projects, small demolition projects, and which will cover about 70% of the construction projects in India, they do not have any guidelines on what to do. In this case, the builder usually dumps the waste in a mixed form. Now we need two kinds of solution. Either the industry needs a solution, a low cost solution where they can easily identify the waste and segregate it clearly so that they can use it, or we need to work with this mixed waste and how to incorporate in concrete. So when we are talking about using it, there are two kind of strategies that people engage with. First is like treating it or processing this waste so that the properties become very stable and very good quality so that it can be used in concrete. The second method is identifying factor of safety in advance, like how much property loss is expected when we are using this heterogeneous waste, and taking this into account when using for construction. So I will just give you an example. Like if you are talking about mixed waste, up to the presence of 20% of brick aggregate, the property loss in concrete is expected to about 5%. But when we go about, if brick content in this recycled aggregate exceeds from 20% to say 40%, this property loss suddenly drops from 5% to about 22%. And if this brick content keeps on increasing, the loss in the compressive strength of concrete become very drastic. So we can have some factor of safeties if we know what kind of mixed waste the industry is generating and suitable factor of safety are designed. So this I want to show about processing part as of now for this today's work. So processing is a viable solution because most of the people do not want to work with factor of safety. They don't want to have a dynamic solution, like they have to keep on updating the solution based on individual project. They want a single stop solution so that they have a reliable solution which can be easily implemented in industry, and that comes through with the help of treatments. So this is an example of thermomechanical treatment. So if we are talking about mixed waste, like if we bring it in under thermomechanical treatment, heating typically removes your organic impurities. The bricks and these other ceramic materials, they center and become hardened, and your typical adhered mortar, which is responsible for reducing the responsible for degrading the properties of recycled aggregate, it gets removed off. So we have worked with it and we have achieved very high quality results. Like if you look at the way the codes are defined, the treated aggregate meets all the standard provisions, which is just, like very few treatment processes have achieved as of now. So even all the properties, and if we look at the final properties as compared to natural aggregate, the concrete prepared, the treated aggregate performs at a level of 93.7% of natural aggregate, which is very close as compared to how the original waste was performing. I was just to say that these treatment method themselves sounds plausible, that okay, the like we are achieving a good technical result, but when people are advocating these kind of research, they often miss out on the part of economics and environmental impact. This happens a lot in India, and if you look at this process itself, the net cost comes out to about 1.549 rupees per kg of aggregate, and carbon emission shoots through the roof. As compared to your natural aggregate, which is available in the market, the typical processing costs are way higher when we are talking about treatment methods. Innovation is not just limited to materials. The innovation should also come into the treatment processes. So when people are looking about thermal treatment, they always look about how to heat the material and how they just burn the material and they test its property. But people often forget there are always cross industry innovations. So there's one recent solution, like not very recent, but it has been there for about 15-16 years in the industry. It's called Schaeffler furnace. This Schaeffler furnace, what it does, it directly concentrates solar energy and creates a very high temperature and acts as a furnace. This has already been implemented in India. It's not a very new technology, but it's not known to the industry. So its cross industry applications are still missing. So if we try to use this kind of technology, our net carbon emission becomes lower than natural aggregate, and the net cost also gets lower than natural aggregate. This type of innovations are needed there to drive to drive the changes, this kind of green changes, and make the aggregates more the recycled aggregate utilization more sustainable. So I am telling you, this kind of solution is not there at 100%. This is just making a more greener effort as a replacement to your natural aggregate and recycled aggregate. But due to limited availability, this solution can further be improved, and this is just an relative shift in this.